Finally, we'll close our work in this section with an overview of modular valves. You may already be familiar with modular valves, including cartridge and stack valves. In this section, you'll learn the hows and whys of modular valves to enhance system design and troubleshooting. For example, you'll see how these valves help designers eliminate many of the problems associated with external plumbing between valves, and you'll increase your expertise in the operating principles and use of these valves.
Stack valves are bolted together in a compact stack, eliminating the need for external plumbing between components. By eliminating the pipes, tubes, and hoses typically used to interconnect the various valve components, the assembly is compact and the directional control valve is always located on the top of the stack. The relief valve should be placed at the bottom of the stack next to the subplate. Flow control valves and pressure control valves are placed between the relief valve and the directional control valve. Using proper procedures when assembling stack valves will produce a leak-free circuit. Clean and check all O-ring seats for damage. Center new O-rings in each seat, and alternately tighten the mounting bolts until all bolts are properly torqued. A single valve stack can be mounted on a manifold block or subplate, while multiple valve stacks can only be mounted on a manifold block. Each valve stack would be used to control an actuator. Stack valves can be mounted on a manifold block in conjunction with circuits containing cartridge valves. Subplates and manifolds have a supply P port, a return T port, and A and B work ports, which line up with corresponding P, T, A, and B ports on the mounting surface. Manifolds and subplates with X and Y ports can be supplied when using directional control valves that require an external pilot or external drain. Watch as the following components are converted to a schematic of a single stack that controls an actuator. The relief valve is placed next to the manifold to provide protection to the circuit. Pressure and flow controls are sandwiched in between the relief valve and the directional control valve. The directional control valve, which only has one mounting surface, is always at the top of the valve stack. This schematic represents a system of 3 valve stacks mounted to a 4-station manifold. The alternating dot and dash lines are enclosure lines. Each component outlined by an enclosure line represents a module with its internal passages. A blanking plate is used to block the ports of the unused station. There are 4 flow paths through each valve stack. The pressure and return passages through the stack assembly connect the pressure and return ports of the directional control valve to the respective ports on the manifold. The A and B work passages through the stack assembly connect the work ports of the directional control valve to the ports of the actuator. The system relief valve is located in the stack closest to the common supply and return ports. Stack valves are available in 4 ISO sizes. The ISO size 02 valve has a maximum pressure rating of 215 bar and a flow rating of 30 liters per minute. The ISO size 07 cartridge valves can be used to perform flow control, pressure control, and directional control, load holding, and logic functions. They are a very compact design that must be installed into special cavities in valve blocks or manifolds. Cartridge valves, used in combination with a manifold, can be used to create a common circuit free of potential leaks associated with external plumbing. Cartridge valves can be divided into 2 design categories, screw-in and slip-in. The screw-in style cartridge valve uses a threaded base to secure the valve in the cavity. Screw-in cartridges use either a spool, poppet, or ball valve element. The spool element can be used for 2-way, 3-way, or 4-way flow functions, while the poppet and ball elements provide for only a 2-way flow function. Screw-in cartridge valves are typically used in low-flow systems where the flow is 35 gallons per minute or less. Some of the available screw-in valve configurations are check valve, relief valve, needle valve, solenoid-operated directional control valve, and manually operated directional control valves. Slip-in cartridge valves are used for large flows, over 30 gallons per minute. They are similar in design to poppet-style check valves and are made to slip into standardized cavities in a manifold block. A control cover is bolted on top to secure them in the cavity. The control cover has passages for pilot flow to operate the valve insert, which you can consider as the main stage in a 2-stage valve. The slip-in cartridge element is controlled by a directional control that is bolted to the control cover. By using 4 slip-in cartridge valves with a directional control on each to operate a cylinder, you will get 12 flow path combinations. Because you can use individual slip-in cartridge valves for each flow path, you can select sizes that are appropriate for the amount of flow. For example, the flow out of the rod end of a cylinder is less than from the cap end due to the similar volume in the rod end. A conventional valve would have to be sized for the larger flow from the cap end, while the individual cartridges allow you to use smaller sizes for smaller flows. The result is more compact, economical valving. Slip-in cartridges are available in several area ratios. The area ratios and the pressure at each port determine whether the valve will open or close. The following are features represented on a slip-in cartridge valve symbol. The area ratio given by the relative widths of the parts of the poppet. For example, the 1:1 ratio shows that the top and bottom of the poppet are the same width, while the 1:2 ratio shows that the top is twice as wide as the bottom. If the valve is used to control flow, it will use a triangle to indicate a throttle notch in the poppet. The closing spring is part of any slip-in cartridge valve. The supply and working ports are indicated by A and B. The pilot port is indicated by A sub P. Manifold blocks should be thoroughly cleaned before installing cartridge valves. New manifold blocks may have metal chips and other contaminants left in the cavities and passages from the machining process. Prior to assembling, the manifold block should be flushed repeatedly. Next, compressed air should be blown through all ports and passages, and each opening wiped clean with a lint-free rag.